Hi everyone and welcome back to the channel. If this is your first time here, my name's Peter. I'm a retired maritime trainer and assessor. These days I'm the captain of a rescue vessel and I conduct private tutoring sessions, and as an invigilator with the Office of Maritime Communications, I conduct marine radio licence exams. In today's video I want to talk about something a little bit different. I want to talk about the sextant. Now, while most commonly used in ocean navigation to measure the angle of the sun, moon, planets, etc. to fix your position at sea, there are some occasions when it can be used in coastal navigation. Like many things to do with boating, we have systems on board and then we have backup systems. When the first or second method doesn't work, we go to another. So being able to know how to use a sextant should be in that category of knowing how to fix your position when other methods are not available. So, enjoy.
Sextant means 1/6 of a circle, or 60 degrees. A sextant is not an everyday object on board a vessel making coastal passages. It's more often used in ocean navigation, when out of sight of land. However, there are a couple of occasions when a sextant can be very useful, and it's as well to know a little about how it works. A sextant is a very high-precision tool for measuring angles, usually the vertical ones between heavenly bodies, the sun, moon, or stars, etc. It consists mainly of two mirrors which are precisely aligned relative to the frame of a sextant. One mirror, the index mirror, is fixed to the index arm. The other, the horizon mirror, is fixed to the frame. The two combine to bring the reflection of the target down to the horizon. The angle between the target and the horizon can then be read on the bottom of the frame, which is marked in degrees and minutes. Look through the telescope and at the same time move the index arm until you see the sun reflected in the silver half of the horizon mirror. Now, work the sun down, make sure you've got the appropriate filters in place, until the sun appears to sit on the horizon, which you can see through the clear half of the mirror. The aim is to get the lower part of the sun, called the bottom limb, sitting exactly on the horizon. Rock the sextant from side to side to make the sun swing on the horizon. And when the sun is at the bottom of the swing, you're exactly perpendicular. Turn the micrometer adjustment until you're satisfied that the sun is exactly on the horizon, and, noting the exact time, read the degrees and minutes from the main frame of the sextant. This is the angle that the sun, or whatever you're shooting, is relative to the horizon. And that, very simplistically, is how the sextant is used. But of course this program is not concerned with shooting the sun. We're looking at how the sextant can be used in coastal navigation. The angle between two objects can be measured with a sextant by using it on its side, what we call horizontal sextant angles. When you can see both objects in the horizon mirror, note the angle on the sextant frame. Let's say you find the angle between lighthouse A and chimney B is 80 degrees. If you draw an angle at 80 degrees to fit both objects, a station pointer could be handy, and then draw a circle to fit both objects and the intersection of the angle, we must be somewhere on this circle, yes? It's the same principle as the position line obtained by a straight bearing, and like this we need a second circle to fix our position. Measuring the sextant angle between chimney B and building C, we find that the angle is, say, 50 degrees. Draw this angle to fit the two objects, and then a circle to fit the two objects and the intersection of the angle. You don't need to draw a full circle. Just where it crosses the other circle will be enough to give the position, which is where the circles cross. Although it's a fairly long process, the result will be even more accurate than the position obtained by the compass method. Getting back to that station pointer, this is a protractor with 3 arms, one of them fixed. Here's an example of its use. You're out in the Sound happily fishing away or just cruising, whatever, when suddenly something goes wrong. You hit a submerged object, or your engine packs up. You call the Coast Guard for help. Their first question is, what's your position? If you know the exact position, that's terrific. Trouble is, not too many people know instantly where they are, and it's obviously essential that the Coast Guard find you, and quickly. The easy way to pinpoint your position reasonably accurately is this, and it only takes a couple of minutes. Place a wristwatch, it won't work with a digital watch, on a flat surface and point an imaginary line from the centre of the watch through the figure 12 to a prominent object that you can see. Let's say the hill, 244 feet at Friar's Head. Now, without moving the watch or the boat, look for another prominent object and draw another imaginary line from the centre of the watch again to the object. Let's say the object is Hulse Landing. The line would pass through 5 minutes past the hour. Now look for a third and final object, say the tower on Muttituck Hills. The line will pass through 7.5 minutes to the hour. If you gave the Coast Guard these 3 times, they would be able to work out your position almost immediately. If you want to work it out yourself, here's how. Set one of the movable arms to 30 degrees, which is the same as the 5 minutes you reckon that Hulse Landing is from Friar's Head. 1 minute of time equals 6 degrees of arc. So, 5 minutes equals 30 degrees. Now set the other movable arm to 45 degrees. 7.5 minutes, the time angle from Friar's Head to the tower on Muttituck Hills. Without altering the setting, lay the station pointer on the chart and move it around until all 3 arms coincide with the 3 objects. Mark with a pencil through the centre hole of the pointer and voila, you have your position. You'll find in this case that you are in position 41 degrees, 05.5 minutes north, 72 degrees, 43.45 minutes west, 7.2 nautical miles due north from Friar's Head. It doesn't matter what the objects are or where, as long as they can be identified on your chart. If your compass is in a position that you can sight across it, you could use that instead of a watch. A hand-bearing compass would be even better. Don't worry about deviation. All you're looking for is the angle between the 3 objects. The other handy use for a sextant in coastal navigation is to find the distance off a given object, such as a lighthouse high on the cliff top. As long as you can see the shore below the object, you can measure the distance off. To do this, you use the sextant vertically. Measure the angle between the light and the shore directly below. Let's say it works out at 47 minutes. Find the elevation of the light from the chart, let's say 75.5 meters, and you now have 2 sides of a right-angled triangle. To find the third, which is your distance off, you'll need to apply this formula. Elevation of the light in meters multiplied by 1.86 divided by the sextant angle in minutes equals the distance off in nautical miles. So, our example, elevation 75.5 multiplied by 1.86 divided by sextant angle of 47 minutes comes out at 2.9878. Let's say 3 nautical miles. Most sets of nautical tables, almanacs and the like, carry tables that give distance by vertical angle. Enter the table with elevation in feet or meters and the sextant angle in minutes, and simply read off the distance. If you take a compass bearing at the same time as the vertical sextant angle, the 2 combine to give a very accurate fix. A variation of the above is to plot the safe arc to pass around a headland, for example. Imagine you want to round a headland at least 2 miles offshore. First, look up the elevation of the headland. It's then a simple matter to find the third side of that triangle, again, either by the nautical tables or the formula. Set the angle on the sextant, and provided you can see a space between the top of the headland and the shore below, it's safe to proceed. As long as you give yourself a good margin for error, this method is quite reasonable. But, as I've said, these types of fixes all have their limitations. A good navigator won't just rely on any one of them. They just help to narrow the possibility of error.
So thanks for joining me today on how to use a sextant in coastal navigation. See you in the next video.